comes the, y'all don't really want it like, yeah. Here comes the, no. Here comes the, oh. Here comes the, y'all don't really want it like, yeah.
Hi, my name is Andy Attenborough, and later we'll be joined by my brother Ryan, who is currently in Africa looking at the evidence of Continental Drift. Continental Drift is the concept that the continents of the world were once part of a large supercontinent that scientists have called Pangaea, and over hundreds of millions of years, that supercontinent has subsequently split apart to form the smaller land masses we know today to be our continents. The idea of continental drift is thought to have first been put forward by a Flemish cartographer and mapmaker named Abraham Ortelius in 1596.
And then again, much more recently, by the German scientist Alfred Wegener in 1912.
Now let's first take a look at Abraham Ortelius.
Ortelius was born in Antwerp, which is now part of Belgium, on April the 14th, 1527, to an influential family. Through work, Ortelius travelled a lot around Europe as a businessman. However, in the 1560s, he started paving his own way, travelling with Gerardus Mercator, who, as we know, is famous for creating the Mercator projection, the most commonly used nautical map.
Ortelius was committed to becoming a scientific geographer, and in particular, he now devoted himself to the compilation of the Theatrum Orbis Terrarum, which roughly translated to Theatre of the World, but we know it simply as the Atlas. After spending his life dedicated to cartography and scientific geography, Ortelius had earned the respect and esteem of Europe, and 2 years before his death, he underlined a very obvious geometric coincidence between the shores of America and Europe-Africa. And this is the first known theory of continental drift. Ortelius, in his work Thesaurus Geographicus, even went as far as to suggest that the Americas were, and I quote, torn away from Europe and Africa by earthquakes and floods. He went on to say that
the vestiges of the rupture reveal themselves if someone brings forward a map of the world and considers carefully the coasts of the three.
But this elaborate theory was based solely on the visual evidence that the continents Africa, Europe, looked as if they could fit with the Americas. So, due to the lack, or rather complete absence of scientific evidence, the theory simply died. But then, 316 years later, a German scientist, geophysicist and meteorologist named Alfred Wegener once again proposed the theory of continental drift. Wegener's theory derived from the same roots as that of Abraham Ortelius. He noted that the different large land masses of the Earth almost fitted together like a jigsaw. He hypothesized that the continents were slowly drifting around the Earth.
The rebirth of this theory was met with harsh and scathing response by the scientific community, as we're about to see in the following very rare footage of Alfred, found in the German National Archives.
The main problem for Wegener, as it was for Ortelius, was the lack of scientific evidence in his theory. Wegener's sole explanation for how the continents had drifted apart was that they were literally moving through the Earth's crust like an icebreaker boat through ice sheets. And he put the force pushing the continents down to a combination of centrifugal force, caused by the Earth's own rotation, and tidal force. More controversy then erupted after it was revealed that Wegener had made flaws in his data, which caused him to make outlandish predictions for the future movement of the continents. However, there were scientists that supported Wegener's theory of continental drift. South African geologist Alexander Du Toit supported it as an explanation for the close similarities of stratus and fossils between Africa and South America, two continents that were supposedly once one. Another strong believer of Wegener's theory was Swiss geologist Emil Agrand. Agrand seen continental collision as the best explanation for the folds and buckles that he observed in the Swiss Alps.
But for all the concepts and the theories of Abraham Ortelius and Alfred Wegener, it was not until the late 1950s that scientists discovered a plausible explanation for continental movement. The theory of plate tectonics was developed in the late 1950s and early 1960s.
As for its relevance to continental drift, most continents, as well as a large body of the sea floor, sit on a tectonic plate. Each plate consists of crust, which is the outermost layer of the Earth, and mantle, a thick layer of hot rock. These plates slide on the preceding layer of the Earth, known as the asthenosphere, which is similar to the mantle of tectonic plates, but is so superheated that it flows, even though it remains solid. This occurs when the superheated magma pushes upward towards the surface, only to cool and be forced back down towards the core of the Earth. It is with this constant shifting of the plates that form the Earth's crust that the continents that sit on them move slowly relative to one another. But now Ryan and I are back off to Africa to revisit his research on continental drift.
We're now here at the Okatumba Research Facility in South Africa to investigate living evidence of continental drift.
Firstly, there is a fern found on most of the southern continents,
And a land reptile found only in Africa and South America. But now we're going to go out onto the plains to find firsthand some real evidence of continental drift.
So what we're looking for here is a certain species of earthworm found right here in the grounds of Africa.
But the exact same species is also found on the continent of South America.
Fresh elephant dung. Pretty disgusting.
Oh, he's not really Oh no. Oh no.
We continued to search the plains for several hours until we finally stumbled upon what we've been looking for, one of 3 specific species of earthworm. Well, that's half the task done. Now it's off to South America.
Hello, ladies. Look at your man. Now back to me. Now back at your man. Now back to me. Sadly, he isn't me. But if he stopped using lady-scented body wash and switched to Old Spice, he could smell like he's me. Look down. Back up. Where are you? You're on a boat with the man your man could smell like. What's in your hand? Back at me. I have it. It's an oyster with 2 tickets to that thing you love. Look again. The tickets are now diamond. Anything is possible when your man smells like Old Spice and not a lady. I'm on a horse.
I'm now flying off to South America to later be joined by Ryan so we can look at more evidence of continental drift.
I've now landed in the jungles of South America. I must be in some sort of native encampment because there is a native hut. And over there is a native clothesline. And there's a native. I found what I've been looking for. Just take a look at this right here. This here is a species of earthworm called Acanthodrilidae. You may remember it. We found one earlier in Africa. You may ask, how does a humble little species of earthworm get to be in Africa and South America? Well, it certainly didn't swim. I think this comes down to continental drift.
I'm now taking the chopper back up to civilization to meet with Professor William Cohen of Harvard University to discuss the geological evidence of continental drift.
There is also geological evidence to prove that continental drift did actually happen. I have here one rock from the continent of South America and one from Africa. And also here is Professor William Cohen of Harvard University. Professor, what are your thoughts on these two rocks? Thus proving that continental drift did actually happen.
I'm now heading down under to the ICMA, or Institute for Continental Movement Australia, to see what they have to say about continental drift.
The Australian government has put a lot of time, money and resources into the research of continental drift. Over the past 4 years, this is what we've come up with.
Well, that was a waste of time.
But now we're going to have a look at some of the effects of continental drift.
When continents collide, they cause the formation of mountains. More mountains causes a higher rate of erosion. An erosion process called chemical weathering allows freshly exposed rock to react with water and carbon dioxide, removing the carbon dioxide from the atmosphere. Less carbon dioxide means a reduced greenhouse effect, so the planet becomes cooler. As an example, India has been colliding with Asia for the last 15 million years. This time period has been one of gradual cooling for the planet, up until modern times when man-made climate change has dramatically increased the Earth's temperature. Another effect of continental collision and subsequent mountain formations is that it can potentially reroute global wind patterns, forcing wind around mountains as opposed to just going straight over. Ice ages are caused in part by the fact that the majority of the landmass of the Earth is located in the northern hemisphere. When cycles related to the long-term changes in the Earth's orbit, called Milankovitch cycles, combine to cause cold weather in the hemisphere, the temperature increase of summer is not sufficient in melting the snowform from the previous winter. So, as more snow and ice accumulate over the subsequent years, it then reflects more sunlight, which causes further cooling, and then hastens the onset of the next ice age. Numerous predictions have been made for what could happen for the future of the Earth, a lot of them differing greatly from one another. But then, when you think about it, who really can tell what will happen for the future of the Earth? Just cash.
Chilling,
There is a native hunting wolf.
chilling on a stop.
Hi, I'm Andy Attenborough. Hi, my name is Andy Attenborough. Hi, my name is Andy Attenborough. Hi, I'm wearing a shirt. Hi, my name is Andy Attenborough.
Scene 2, where Andy is gay. Everybody's right.
I'll actually die.
It's like 3 centimeters.
I could fall over.
Alright, go. Do you need sound in that bit? Because I was talking over it.
No, no, it's a montage of... That's why there's pretty much no signs of life here.